Hi, good afternoon, and welcome to our event today. Um, the subject for today is digital transformation using AI manufacturing. My name is Nasir Manan. I'm the principal engineer here at CCAT. We're joined today with our technology partner SphereGen and Dinsmore, and then his team here as well. We've got an exciting presentation today, and we're going to go through a lot of different use cases of artificial intelligence. We'll try to describe what AI is and its application in manufacturing. But a couple of key introductory um, reminders. So we are an ITAR facility. So for those of you that are here in person, I just wanted to remind you, please refrain from taking photos or images of the presentation or anywhere around the lab. If you, if you get up to go to the bathrooms that are over here on my left, your right. Both of those doors are available, but along the way, just refrain from taking images. The fire exits are going to be straight out the door that you went through the reception area where Susan sits, right opposite the bathroom doors. And then just a reminder that at the end of this presentation, we're going to send out a link for you to submit a survey. We'd love to hear what you thought of the presentation. Give us feedback on what other subjects you'd like to know or hear about, and we'd be happy to set up future presentations. So for the virtual audience, we do have a chat area of the Zoom call. And if you go ahead and place your questions in the chat area as they come up, when we get to the end on the question and answers, we'll have those questions read out and answered. So a little bit about CCAT. Our vision, transformative solutions for a connected world, and our mission statement is to lead the advancement of applied technologies, power the workforce of the future, and inspire change. CCAT is an applied technology demonstration and training center that validates, demonstrates, and assists with the adoption of leading-edge technologies to enable a resilient supply chain, industrial base, all while providing vital training and upskilling. We have those are the three key areas there that you see: the advanced technology centers, the workforce trainings that we do, and then strengthening the supply chain through digital transformation technology adoption. Here are our three labs. We have a composites center that's located in another building at Goodwin. We have our digital and additive labs here at the Advanced Technology Center. You're on the side of the Atom Lab at the moment. On the other side is all of our additive technologies. So the way that we support technology adoption is done in 5 steps. One, we hold a lot of introductory workshops so that companies get introduced to technologies that they may not know exists. And then we follow that up with technology demonstrations. So we either do that here at our lab with demonstrations that we set up on our parts, or we can do one-on-one demonstrations with your parts or processes. So if you wanted to see a collaborative robot working, if you wanted to see deburring, if you wanted to see a model-based workflow, bring us your parts, bring us your problems, and then we'll try to show you how to use technologies to overcome those issues. And then with that, if you're interested in adopting the technology, we do have money available. This is grant money available for you to help subsidize the cost of onboarding this technology. We'll hear more about the grant programs from my colleague Eileen Candle at the end, and she can describe all of the different programs that we have available to the state of Connecticut for manufacturing companies. Following that, we do support the technology onboarding, and then also technology trainings with our digital thread lab, and then any trainings that we hold here at the Advanced Technology Center. Most of this is at little to no cost to you as a manufacturing company, so long as you're incorporated in Connecticut. And then we do from time to time have regional programs where we can support companies outside of Connecticut as well. So a little bit about the digital transformation program. This is, again, a support for small to medium-sized manufacturers. The services here, as I just mentioned earlier, are technology demonstrations, evaluation, and solution determination. That's when we come on site. We can tour your manufacturing facility. You can point out where you see issues, and that's where we can bring those notes back with us, talk with our technology partners, and come up with solutions. Funding assistance, again, through the different grant programs. We do application training. So if you're looking to adopt, one of the AI technologies that we'll talk about today, we can host a training, and then project support. What we have is, if you go to the website, you see there in the middle there, CCAT.us/industry40. You'll see a consultation form link. So this is a no-cost consultation. If you wanted to get started with a project, you wanted to take advantage of this digital transformation program, that's the way to get started. So you go to the website, click on that link, just fill out the form and submit it to the contact that's listed on that form. That's how you get started. So some of the example projects include industrial Internet of Things, digital twin, edge computing, machine learning, artificial intelligence, extended reality, and robotics. The Digital Thread Lab, this is a new inclusion at CCAT. It's a great opportunity for manufacturing companies to get their workforce trained. These are 3 to 5 day training courses, and it gets in depth on model-based workflows. So you can see here on the slide, we do on-site training, 40 hours a month to reach 500 people per year, and support SMMs and OEMs in the region. Career pathways, there's targeted career pathways created with input from employers to upskill design, manufacturing, and quality personnel. And then we have our digital portal online, which is an on-demand digital resources, self-assessments, and training signups. Registration is currently open, and courses begin January 23rd. Down at the bottom right of the slide, you can see the link, the website address to go to sign up. So it's CCAT-DTL.com. As I mentioned, this is a quick overview of all the different grant programs. Again, we'll come back to this at the end of the presentation. My colleague Eileen will describe these in more detail for you. So on to the subject for today, applications of artificial intelligence for smart manufacturing. Again, thank you for attending today's event that is focused on the applications of AI for smart manufacturing. We've lined this particular presentation up in 2 parts. The first being introductions and the importance of the subject matter, along with example applications. And in the second part, you'll hear from our technology partner, SphereGen, on AI embedded technologies that exist today and their benefits to manufacturing. So before we get started into the subject, as it relates to manufacturing, let's first explore what is AI, what is artificial intelligence. So artificial intelligence is a field of computer science that aims to create machines and software systems that can perform tasks typically requiring human intelligence. This includes capabilities such as learning, reasoning, problem solving, perception, understanding natural language, adapting to new situations, as an example of a few, AI systems can be designed to perform a specific task, like recognizing objects in an image, or multiple tasks simultaneously. The ultimate goal of AI research is to develop machines capable of simulating the full range of human intelligence, known as artificial general intelligence. So AI works by using various techniques and algorithms to simulate human-like intelligence. As I mentioned, the core principle is to mimic how humans learn, reason, and solve problems. This slide presents an overview of some of the fundamental approaches used in AI systems. So here you can see natural language processing. This focuses on enabling AI systems to understand, interpret, and generate human language. This involves tasks like sentiment analysis, machine translation, and chatbot development. Expert systems are AI programs that mimic the decision-making abilities of human experts in a particular domain. These systems rely on a set of rules and knowledge base to solve problems, provide recommendations, or make decisions based on specific criteria. Machine learning is a subfield of AI that involves training computer systems to learn from data and adapt their performance without explicit programming. This is achieved through algorithms that identify patterns in the data, allowing the AI system to make predictions or decisions. Deep learning, this is a subset of machine learning that specifically uses deep neural networks with many layers. It is especially effective at processing large amounts of data, such as recognizing objects and images or understanding human speech. Reinforced learning is a type of machine learning where an AI agent learns by interacting with its environment and receiving feedback in the form of rewards or penalties. This method is used for applications such as training robots. Evolutionary algorithms are optimization techniques inspired by the process of natural selection, where AI systems evolve their solutions over time through a process of trial and error. Evolutionary algorithms are used in applications like optimization problems. AI utilizes these approaches and techniques in various combinations to simulate human intelligence. The complexity and function of AI systems significantly depend on the specific application and state of the technology. So let's look at the approach neural networks take for simulating intelligence, loosely modeled after the structure and function of the human brain. So human neurons and artificial neural networks are interconnected in the sense that artificial neural networks are inspired by and modeled after the biological neural networks found in the human brain. However, they operate on different principles, and their similarities are more conceptual than direct parallels. So human neurons are the primary cells in the human nervous system that transfer and process information using electrical and chemical signals. They are connected through synapses, which allow them to transmit signals to other neurons. The human brain has around 86 billion neurons, and the way these neurons connect and communicate with one another allow for complex information processing and cognition. Artificial neural networks in AI are computational models that take inspiration from human neurons, but aren't exact replicas of biological neural networks. ANNs, or the artificial neural networks, consist of artificial neurons or nodes organized into layers. These nodes process inputs and transmit information through weighted connections, somewhat analogous to synapses. The weights of the connections are learned or adjusted during the training process to find patterns in the data and make predictions or classifications. This video demonstrates a neural network at work, where it processes images of handwritten digits as inputs. Successive layers in the network take these inputs, which are weighted sums of outputs from neurons in the previous layer. An activation function is then applied to this sum, determining if the neuron passes its input to the next layer. The behavior of the activation function is tuned during the training process. Once the system is trained, It can accurately predict the drawn number in the image at the output layer. So human intuition and experience, combining AI with human intelligence leverages the power of human intuition, creativity, and years of experience in manufacturing domain, which can lead to innovative solutions that AI algorithms alone may not easily discover. This leads to more dynamic and adaptive production environment. In summary, the key relation between human neurons and AI neural networks really is their shared foundation in the concept of interconnected processing units. AI neural networks are simplified and abstracted versions of biological neural networks with the goal of replicating some aspects of human intelligence in machines. However, they are not direct representations of human neurons and are and their operation is fundamentally different on various levels. Generally, by augmenting artificial intelligence with human intelligence through the use of AI embedded technologies, we can certainly benefit from enhanced decision-making, increased efficiency, and an improved ability to solve complex problems while reducing error. So what is smart manufacturing? Specifically in applications to manufacturing, companies are currently benefiting from AI-enhanced technologies that enable smart manufacturing. The term smart manufacturing constitutes advanced manufacturing systems that utilize data-driven and intelligent automation to operate more efficiently, accurately, and flexibly. It involves the integration of physical and cyber systems to monitor and optimize the manufacturing process. The main benefits are realized through streamlined processes, improved quality control, increased productivity, and overall just reduced costs. So let's look at how AI is used in each application. There's a variety of applications. We're looking at predictive maintenance, quality control, production planning and scheduling, supply chain optimization, customer service and support, safety and compliance. And then I'll also show how AI is used now in physics simulation. So predictive maintenance is data-driven maintenance strategy that uses AI and machine learning algorithms to predict potential equipment failures before they happen. In analyzing data from sensors and other sources, AI can detect patterns that indicate an impeding failure. This allows plant managers to schedule maintenance proactively, reducing downtime and repair costs. AI can be used to improve quality control by analyzing data from sensors and detecting defects in real time. This allows manufacturers to catch defects early in the production process, reducing waste and improving product quality. AI can optimize production planning and scheduling by analyzing historical data and predicting future demand. This allows manufacturers to adjust production schedules in real time, improving efficiency and reducing inventory costs. AI can optimize supply chain operations by analyzing data from multiple sources and identifying bottlenecks in the supply chain. This allows manufacturers to take strategic decisions to reduce lead times, improve delivery time, and reduce transportation costs. AI can improve customer service and support by automatically answering routine questions and providing personalized recommendations to customers. This improves customer satisfaction and reduces the workload on customer service. And finally, safety and compliance. AI can improve safety and compliance by analyzing data from sensors and other sources to detect potential hazards. This allows manufacturers to identify safety risks early on and take corrective action before accidents occur. AI can also help manufacturers comply with regulations and standards by automatically monitoring and reporting on compliance. So these past couple of slides that I've written, in fact, is a demonstration of the use of AI, because AI generated a major portion of this presentation. And I just wanted to let you know that that's why I've been reading the slides, is because I wanted to make the point that AI actually generated what I needed to say about each subject matter. And this is an example of how I can use AI to my benefit, instead of going online and searching, reading papers. I mean, obviously you want to be able to do that, but to augment myself and be able to leverage AI to give me, to ask it to produce a presentation on the applications of AI for manufacturing, you can see the benefit. It saves a ton of time. A presentation that otherwise would have taken me maybe a week to produce, or maybe a couple of days to produce, literally took me like an hour, 2 hours. So it's that in itself is a huge time saver. So one of the things that I wanted to bring up, is on the physics side. So normally in engineering or in manufacturing, there's a lot of analysis or simulations that take place. So simulations can sometimes take a long time to calculate, especially if you're doing physics-based, where, for example, let's look on the next slide of simulating how water behaves in a container, or how water reacts to barriers that are in front of it. So take, for example, a water droplet falling into a cup of water. How does the water that's in the cup react to that drop as soon as it hits the water? Calculating something like that in fluid dynamics can take hours or days, depending on how refined the mesh is, or how many points you have that represent kind of the water molecules, and then how they behave. You can actually train AI to learn that physics and then execute that simulation in seconds to, in minutes to seconds, rather than hours to days. So in conclusion, AI has a variety of applications in smart manufacturing, from predictive maintenance to quality control to supply chain optimization. By leveraging AI technology, manufacturers can improve efficiency, reduce costs, and improve product quality, ultimately driving greater success and growth for their business. Again, if you're online, please do use the chat area to add your questions in. We'll get to the questions at the end. At this time, I'd like to introduce Ted Dinsmore from SphereGen to continue with the second phase of this presentation.
Thank you, Nasir. You want to just answer that question about what you use to generate that? Was it ChatGPT or something else?
Yeah, there was multiple. So there's ChatGPT, and I believe I used GPT-4. It wasn't 3.5 turbo. It was GPT-4. I believe GPT-4 is trained up to, is it March or April of 2023? So it's one of the more recent, it'll have more of the recent information. If you use 3.5 turbo, I believe that's from 2021. So one of the things about AI or using large language models, you gotta check the date that it was, to what date does it have information on? So if you're going to ask it recent events, it's not going to know. And then for the image generation, some of those images were from images that I had from previous presentation, and other ones that I needed to generate, I used AI to generate those images. So I gave it a text and I said, please generate an image that shows this, 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 and this. It generated it for me and I stuck it in the presentation.
Very good imaging. Very nice. Thank you. Good afternoon, everybody. And this is a small group here and then a group online. So I'm happy as we go through this to have a conversational aspect as well. So feel free to ask questions. Hi, John. A lot of good friends in the audience. Thank you for coming today, everybody. I'm Ted Dinsmore. I'm the president of SphereGen Technologies. We are based in New Haven, Connecticut, Pune, India, Toronto, and Dublin, Ireland. We've been in business for about 15 years. A lot of people know us, particularly in the Connecticut area, about our work in augmented and mixed reality. And I just kind of want to touch, because we've been doing augmented virtual mixed reality for about 7 years, Andrew, 7 years. Andrew and Eric are here with me. And we also have been doing AI and intelligent automation with our partners UiPath and Microsoft for the past 4 years. And this started out a journey in what was called robotic process automation. Now that's been relabeled to intelligent automation. And we really worked on how this would help our customers in manufacturing and in healthcare. We also do create our own applications, and we actually even support our own commercial products in the cloud. Um, so a little bit about what we've been doing with AI in manufacturing at a very high level. We've been doing a lot of work with order processing processes for some of our clients, and that is automation of basically orders coming in. What are the exceptions? What can we deal with? What issues can happen within that process? It's been fascinating to work on because we've taken one client in order processing was really they would take about 20 or 30 different people to look at the issues on the order processing, and they're now down to about 3. So we've seen huge cost savings in the automation space. Shop floor and training just as well. Training is faster and quicker when using AI models. And then just general streamlining. Nasir touched on some great areas in supply chain, which we'll touch more on. But we're just seeing tremendous amount of uptick using AI for just administrative tasks, both in manufacturing, through financial applications and operating places. We start out thinking, okay, we're going to be able to automate simple processes using AI 3 or 4 years ago. And we start out doing a lot of work around text to voice translation, things like that. And we really have evolved that thinking, and hopefully you'll see through some of our talks today what we're talking about. We're going to actually show 2 full demos. One demo that Nasir has here at CCAT that can be seen anytime. We have it at CCAT around material certification, and then a second demo around quality. So we really want to get the conversation going about how we're using these things to help manufacturers today. There's been a lot. As everybody, I asked GPT, what are the perceptions of AI in the industry? And Nasir covered a lot of these. That the smartest tool in the factory floor will be artificial intelligence going forward. AI manufacturing is not about replacing humans. It's about augmenting what humans can do. And then the future of manufacturing is not just automation, but intelligent automation. And we really like that phrase, intelligent automation, because we can automate a simple task, but how do we make it better? How do we improve the process in the same time? And that's kind of the crux of what we've been focusing on the past 4 years. So just want to talk about some of the benefits, and Nasir did a great job on some of these points. Better decision-making processes by using AI. And cost savings. We really want to drill down into why do we say cost savings in AI manufacturing. One is improved predictive maintenance, as Nasir talked. We have a tremendous amount of maintenance prediction pieces in AI, and I've got some great examples I'm going to be showing you today. More efficient use of the raw materials, and then overall better planning, increasing your workforce management against shortages, improve supplier chain visibility, improve provider management, and overall, what does that equal? That increases a better competitive advantage on you. We've worked so many times over years to increase our optimization of what we're doing, particularly in manufacturing. AI has given us that extra bit of tools that we need to increase it. So I would highly recommend, if you are interested in AI for manufacturing, there is a white paper, and I've got a copy of it here, around manufacturing for 2030 project. Highly recommend reading that entire paper. It really helped me understand and think about more how we can use different components of AI in manufacturing. It was a think piece that was written about 2 years ago now, and it really helped me understand what are the key concerns about AI in the industry. Well, the key ones about the fear of replacing humans, right? We all know this, and really all the trajectories of every study we've seen so far have said that's actually the opposite. We are actually having more workers, but more intelligent work going on. So less mundane work that people are doing. Safety of IP is a big thing. When we're putting out those secrets about, and Nasir, when he started out with something, this is an ITAR compliance spot. When we're putting out that data about how our processes work, that's kind of dangerous, right? That's something we as manufacturers should be concerned about, right? if we gave out all our secret sauce of how we put that component together, I'll give you one similar example. We're working with a client that said, I don't want anybody to know what my network is, right? What my routers are, my IP addresses, all that sort of stuff. But yet my engineers are using ChatGPT and they're doing all these things. I'm like, yeah, these are really concerns that we need to have an understanding as leadership in manufacturing, particularly to know how to deal with. And you can deal with these issues. It's how do we provide the tools to the workers in AI to provide that security for us. Does that make sense, everybody? I don't want to belittle that issue because it's been talked about a lot and it really is real. And there are ways we can restrict how we use AI in our companies. AI ethics is also a big impact. So what are the real challenges to AI adoption? Not enough internal expertise, I think, is one of the biggest. Access to data is getting better and better, but understanding the business use case. Now, what we're talking about today, we're showing you examples of where we're using it with customers today. And I think that's the best way for us to educate other people about what can be done with AI, because there is tremendous amount of use cases that we can do. What makes sense for your organization? How do you implement AI and make it successful for you? Understanding your business use case and how you can apply it really is a key crux to the challenge for AI adoption. We're in that hype phase right now with AI. And I know it's been hype for the past, 6 months, a year, right? Everybody's excited about AI. It has a lot of potential. How do we use it? How do we get it ingrained in our processes? We know it'll help us. How do we actually achieve that? So I'm going to talk about some of the, so this is the high level part's over, okay? Everybody good at that? So I wanted to talk about the top use cases we see in manufacturing, and it's here to touch on a number of them. But this one I think is one of the best ones I've seen is around using cobots for manufacturing and how we actually can use cobots. This is an example of preferences before I play it of Amazon, what they've been doing with AI. Has anybody been watching what Amazon's been doing at all? Is anybody familiar with it at all? Okay. So hopefully it's been entertaining to you. The Amazon uses cobots in conjunction with their order and pick process, okay? Process. So what they're doing is actually lining up the cobot for the picker to pick the next item in the process. Now, what they're doing is using AI to make that more predictive, to make that actually quicker for them. Hopefully no sound. Okay, can you guys see all that? So the cobot is they're moving the material up to the picker, and what they're using the AI to do is to line up things quicker for them. You can see there's a wait time right there. Let me try to pause it. There's a wait time that the person's waiting for that next thing to pick. This actual wait time you can reduce by using AI. And what Amazon's been doing tremendous amount of work. How do we make that quicker? How do we line up everything as quickly as possible? I just thought that was a great example of using AI for how we can actually make a process really quick. You're continually going to try to improve your processes. You still got to help humans. Humans are in the process. We have to figure out ways to help people in that. Okay, so now we're going to go to our next one. So we're going to space out the demos so I get to talk a little bit because I love to talk. And this next, our first demo is going to be how we automate a material cert process. Now, as everybody's aware of material cert, right? Raw material comes into XYZ plant. We have to figure out what that raw material is and put it in many different systems. So we worked with one of our clients and we actually have a material cert process. Go ahead, Eric.
Yeah, thank you, Ted. So yeah, for the material cert process, there's a lot of manual work. Once they receive this material, then they will scan this document. They'll enter it into these various different systems. You could have a lot of these different formats because each vendor that comes in will have their own material. So this is something that's it's tedious work. It takes 10 minutes per entry. They've got to have full focus for those 10 minutes. So there's a lot of benefits that you get from automating this process. So the first hurdle to automating the process is actually understanding the data in a way that a computer can work with it, right? So you've got just a document that's been scanned in. You need to pull the data out. And so there's a couple of important components that allows that to happen. So the first is with OCR, right? Optical character recognition. It's, there's all these different engines from, various Microsoft, Google, whoever, and they all have their own kind of way to handle that. But in terms of what you're doing, you just feed it some data and it outputs the best understanding that it has for the text. So you can do all kinds of tests and verify, what is the most accurate for your particular use case. There's all sorts of things that might throw the systems off. So like if it's a poor quality scan, if there's handwritten content, the different engines might handle that better or worse than each other. So you just choose whatever engine works best for your situation, and then you can start the document processing. So, we, for this particular demo, are using UiPath, and they, can take in that data that's been output by the OCR system and start to classify it, right? So as part of the setup here, each of these kind of vendors that have their own document format, you're going to feed that into a training system, and you're going to identify, I need, this field, this field, this field, because all of them map to one kind of set of information, right? They're all materials certification documents. So once you have told the system, this is what this field contains, then it will handle the OCR input and turn that all into the unified kind of format. Once it has that information, then it's very simple to output in that into as many systems as you need, right? If there's, all these several internal systems that each need a copy of this data, then you can supply it in this way. And so, the runtime is just as simple as the time it takes to scan that document when it comes in, and then another couple of minutes for the robot to run. And something you can do as well is like, we're working with AI here. The OCR systems especially might not have 100% accuracy. So if you're concerned about, is it going to be able to understand exactly every piece of data, you can go send that to a human to be validated. And then instead of a human doing all of the work to enter every piece of data in all the systems, well, now you're just saying, hey, does this look good? And send it back off to the automation. So I'm going to go run the demo itself. So this is something that's pretty quick. We're just going to go basically replicate the process, have, a volunteer from the audience maybe come up and just enter a piece of handwritten content on one of these documents, and then we'll send it into the system and see that it's processing properly. I'm sorry. Yes. Do I actually stop sharing? Sorry. Yes. Thank you. So can we have anyone like wants to enter a piece of handwritten content? It's very, yeah. 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 And so all you're going to do in this top right hand section, you're going to enter an order ID. And so this can be in kind of whatever format you think an order ID should be, right? And again, it's going to be processed by a robot. So if your handwriting is pretty clear, it should understand it. If it's, something that a human might struggle to understand, an AI also might struggle with it. Yeah, absolutely. That's like a good reason why you would want a human to validate that. This is set up, right? All right. So now I'm just gonna have you take a picture of that. I might actually have you move that off just so it's not like, surrounded by other documents. And you're just gonna take a picture of that. And now I'm just gonna set up an email. And yeah, absolutely. We're just showing the handwritten content. And the MCD is the subject line. And then, who we send it to? Yeah. All right. Let me bring up the email. So when it shows up in the inbox, then we can start the automation. It will pull the new email that's come in. It pulls the most recent unread message that matches this format, right? This is an example here. So it has MCD in the subject line, so it knows what we're processing, the material cert demo, and then it will kick off into the automation. Okay. And let's just see, for example. Take a look. Oh, okay, so we've got the image. And scan looks good. So it should be able to process this. The only thing that might confuse the AI is that there's a little bit of shadow there, but we'll see how it handles it. Mark it as on red again. Okay. Okay, so the automation is running now. I think this system is maybe a little bit underpowered, but because there is like a few things that it's doing here, right? There's a good amount of local processing, especially for the document understanding portion. The OCR is kind of offloaded more to the cloud, but it will take, a moment here, pull that information from the email, send it off, get the OCR information, then process the document, and it's going to open up a couple of forms and start inputting into them. Let me make sure I can check its data.
It's hard to actually show an AI at work, right?
It is. This is very much a process that it's automation. It's meant to be going on in the background without humans watching it, right? That's the whole point is, you take human eyes and focus out of the equation.
So here's filling out the forms.
Yep.
Right.
Now open. Let's just watch the order ID, especially because that is the handwritten content. So it picked up that we have the Cliffs vendor. So A3124.
Is that your roadness here? Okay,
Okay.
good. Yeah.
Very good.
Yeah.
And so it's going to open up a second form as well, just to represent the kind of multiple inputs. So, we're going on just a couple of pages here, and then there's 2 inputs.
So is that clear to everybody how that works? So we took an image of a handwritten and typed piece of paper, and we translate that using AI and put it in multiple different systems automatically. Whereas that would be a manual process that someone would have to go and figure out, look at it. We've automated that whole manual process. Does that make sense? Questions while it's running? Go ahead.
Spec will have limits. So do you check against limits here?
Yeah. So we do a validation. This is a demo version, but yeah, in the real version, we did, we checked against like a control table. I was mentioning there's certain material that is abbreviated different ways from different forms. So it may mean one thing on one form from one vendor, may mean a total different thing from another form, another vendor. But we have to translate back to that code to go to the ERP system in this case, for the one simple value that's singular for the multiple inputs. So, and learning the AI module we had to train that, of course. But once they learned it, that was really fairly very accurate. We were very pleased with that part.
Okay. Yeah.
Go ahead.
Yeah, I have a question. So you mentioned that when he took the picture of the document, you mentioned that the shadow may have affected the AI. Is there a way that that information could be misread through the AI when it's being implemented onto the form? And then is there a system to recognize where discrepancies may lie?
I would say it's really dependent on the training, right? Because there's a lot of training that's been done to the documents already, or to the OCR engines already. But you know, if your specific condition has something like that, where a lot of the input that you're sending in has these kind of shadows, then part of the training process is you identify the documents, and anytime the AI will tell you, you know, this is what I think is in this document, and any place that you say, no, this is actually wrong, you know, it will add that back into its training and try to correct it. So I think, like, you know, typically you'll do this in a way where you kind of try and eliminate those environmental variables that you can, because, you know, you want to make the data as good as you can on your side, to, you know, give the AI the least hard time. But also, if you are giving it a hard time, right, you can continue training and continue improving the model.
And actually, just to add to that, all of this data usually comes back as a threshold. So we have some idea of how certain it is of what it's reading. And that's part of how we can basically build in backups, where if it encounters something it hasn't seen before and it's not, you know, 90%, 95% sure of what it is, we can actually have the system react to that. And as Eric was mentioning earlier about having a human in the loop to kind of validate stuff, if we get a request in and it says, oh, I'm only 30% sure what this is, what ends up happening is that ends up getting forwarded to a person who's actually in the loop, who then can validate and say, okay, this is actually what this is. And so that this comes back to kind of the key point of the goal here is, you know, AI is not at a point where it can fully replace people. It's at a point where it can lessen their workload a little bit and make it so that instead of somebody manually needing to do this 50 times a day, instead they just need to spend a little bit of time each day validating specific pieces that maybe the AI can't fully figure out.
So other questions? Great questions. Does that make sense? You see how we're saving a lot of time. We've been working with AI, as I mentioned, for about 4 years, and we went back retroactively to one of the hospitals and healthcare, how much we've actually saved them in time. Now, this was from COVID forward. Over the past 4 years, we've saved between $2 and $4 million in time on a aggregate of $60 an hour rate over the past per year. So it's been significant savings doing this. In that case, it was a lot of nursing time, which is actually more expensive than most. And it did free them up to help with patients. That was a very critical thing for that process. So, okay, that would be. Don't use that. Okay, so I want to talk a little bit about predictive maintenance. Predictive maintenance, we see a tremendous amount of in failures and in historical data, looking at how we can prevent maintenance, have better preventive maintenance using AI is a really clear use case for AI, because we have all this data about that material, all this data about that component. Now we can actually train it to learn and taking that data and actually understand what are the failure rates, what is the process, when should we be doing maintenance. Now, a lot of that stuff is in people's heads. Honestly, a lot of our maintenance work is done by people that really know their products and their material. their machines and they know how to maintain it, right? That's intuitive. What we're trying to do is take that intuitiveness by gathering IoT data about that machine and actually bring it forward. And I'm going to, hopefully this is a video, right? This video, guys? Yeah. Okay, now this is going to be a little quiz, okay? Everybody in the audience here. Now you're going to be hearing 3 engines, okay? Now listen very closely. One of them has a problem, okay? I want you to listen to this very closely. Hopefully work on the speakers, right, guys? No sound. No sound. How do I do this? Sorry. And shy slow. Go to here. And undo that. Okay. Sorry about that. From current slide. There? No. From current slide. Okay. All right. Hopefully this working out. Anything? It's paused. Okay. That's C machine. Okay. Which one had a problem? Anybody? Hard to figure out, right? Any guesses? Okay. C. Maybe we'll try it again. How about that? Let me restart that again. Listen again. Did you make it louder? Can we make Which one is it? Okay, what'd you say, Nedu? Go ahead. C is different than A and B. Okay. Any other guesses? Anybody? A actually it's a bearing problem, right? So what we're doing is using AI. And now, in preventive maintenance, somebody that would know that machine would hear that immediately, right? That's a human listening to a machine, looking at a machine, saying, "Hey, there's something wrong here," right? Very natural for us to do as humans. Now, think about the human is walking by, listening to the machine. Oh, there's a problem. What if we have AI listening to that machine at all times, right? And we train the AIs to say, hey, we've got a problem. There's a bearing sound. This is a very clear use case for AI consistently listening to those machines and saying, hey, there's a problem. There's a potential problem here. Then alerting a human to look at it. Does that make sense? This is like the clearest use case for AI in my mind. And predictive maintenance is so clear because we actually can use voice, we can use sound, and we can use pictures to understand what's going on with that machine. Think about it also, and Nasir showed it in the physics, chemical processes. When you're doing quality and doing predictive maintenance, when chemical processes involved, it's very clear to know what's happening by looking at the beaker or looking at the cylinder. Understanding those pieces are really, really good use cases for AI. Make sense? Everybody agree? Go ahead, Andrew.
So I'm just going to add to that. Basically, there's CNC machines here, and you need to replace, the cutting portions on the CNC machines, and they put out a lot of information. And you can train an AI system on that information to help try to determine maybe a little bit before it becomes kind of, absolutely necessary that you may need to replace a part. And this is going to allow you to kind of, keep less inventory because you're going to get warning with enough lead time that then you can order it exactly when you need it, rather than necessarily needing to have the parts on hand or needing to basically wait until you realize, oh, this needs to be replaced because your parts are coming out faulty.
Right. Good point. So I want to kind of move a little bit, taking that example of the machine with the preventive maintenance. Now, we talked a lot about digital twins in the past. It's been a constant subject in Industry 4.0 for several years now. So how does digital twins play into AI? Is there a relationship? Well, of course, there's a relationship because the data gathered on the physical machine, we can then do simulation on the virtual machine with a digital twin. Now, how does AI help that? Well, when we're taking the digital twin and we're saying, okay, now do your simulations, we can simulate all kinds of things that we think of, but let's train an AI module to actually then take all kinds of variations on the simulation. So this is a real clear use case of you combining what we talked about Industry 4.0, digital twins. Now, what's the next step of applying AI to those learning simulations? Make sense? Everybody good with that? Okay, good. So I want to touch, and Nasir touched on some of these as well about supply chain. We haven't done, completely honestly, we've done a lot of work on order processing. We haven't done a tremendous amount of work on supply chain, but we know that through the work that peers of ours have done is around the pattern recognition and channel mapping. As supply chain's been changing over the past 4 years of all the issues, we've had a lot of pattern recognition changes in the supply chain. There are a number of use cases. I think IBM has done a really good job, by the way, on that. I'll give them a plug on doing work on AI on supply chain. We've seen really good modeling coming up there. That always shocks me. So we want to talk a little bit about the elements of within the supply chain, and as Nasir talked about machine learning, how we can actually do predictive demand based on that. A lot of that is based on, we currently are using algorithms for our predictive demand. Our supply chain, we have an algorithm. We say, okay, here's much material we needed. Here's much material based on what we had before. What are we actually doing? We're feeding that model, feeding that data into the models and allowing them to come up with some new predictive learning on the demand. This has been really interesting work. I think it has been happening a lot in pockets around the manufacturing world. There needs to be much more on predictive demand. There's a good opportunity there for AI to play a major part. Inventory management is just straightforward for AI. When you're talking about demand forecasting, about automating replenishment, about real-time inventory, about supplier relationships and customer service, inventory management is a very clear use for how do I take a manual process that's going on all the time and make that a more automated process with AI. So I'm going to turn it over to Andrew to talk about how we're using AI to boost product development. And this is the demo, the next demo.
All right. Hi there, folks. As Ted mentioned, my name is Andrew Guagliardo. I'm a software developer at SphereGen. You heard me talk a little bit earlier in the presentation a couple of times as well. So you can use artificial intelligence to help boost product development. The key here basically is that it can help you very early on in the process. It's going to help you get creative and basically see variations. What's really useful here is that it can just generate a bunch of different ideas, and then you can choose kind of what to refine on. And so the key here again is that, you know, a person still needs to be in the loop, and a person's still going to be the final decision maker. Good example of this is basically there's a system called VizCom, and they allow you to basically take your sketches and then they can turn them into 3D renders. It can save you the time of basically generating the 3D renders ahead of time and allow you to kind of validate that something looks like something you want to move forward with to then create your actual CAD models for actual manufacture. And, you know, the key here again is just doing that translation, right? So I have an initial idea, an initial sketch, and rather than maybe necessarily sitting down and doing, you know, 40 different sketches, I might still want to do that. I can take those 40 sketches and feed it up, ask for variations, and then get a, you know, another 100, 200 back. And the key here is that, you know, again, this is an augmentative process. So it's just helping you explore ideas and maybe see things that maybe you haven't thought before and provide you a bunch of different options. So actually, I'm not sure if these will play. There we go. So you can see here, this is like an example, right, of taking this 2D sketch and then just making it into a 3D render. And then next we'll see just some quick examples of doing that yet again, and then also potentially showing you a couple of different options that are available based on what you've requested. And so these can be combined in multiple ways where you can feed it a image prompt basically, And then you can also feed it a text prompt. So you can give it your image and explain what it is. And then you can also ask for what sort of changes or variations you would like to see on that. The key here, at least in my opinion, is that this is really powerful at the early stages when you're kind of trying to nail down maybe an aesthetic design or a form. When you're getting into kind of engineering, you're going to need to potentially, add in some additional systems to potentially do some, validation, like Nasir was mentioning earlier, where you might want to do physics simulations or doing sort of tests to make sure that it's actually going to fit the spec that you need. So this was also touched upon a little bit, but AI is really great at providing marketing insights and doing things like helping you with customer service. Again, we mentioned Amazon earlier. They're also using this to basically collate all of the reviews that they're getting and basically, consolidate that down. And this can also be used to allow you to kind of perform generalized market research. Again, this is something that's going to kind of help you get a kickstart, and then you can go and then validate that yourself because you're probably going to have a lot of domain expertise, and the AI is just going to kind of get you started. But this could also potentially be very useful if you have a support ticket process or anything like that. You can take all of the data that you're collecting through your support ticket process, train an AI model on it, and then query it with requests. And you can start getting information about maybe what the most common type of support requests you're getting are, or where you're seeing times where you need to actually replace parts. And you can use that to kind of improve your product or improve your customer service. Any questions about either of those two use cases? All right. So now we're going to talk about kind of a next demo, which is using artificial intelligence to do object detection. And this is specifically about detecting custom objects. And so we've talked about this a little bit at a high level. I'm going to get in a little bit more detail for this. But the basic goal here is if you want to check that a part has been assembled correctly, or potentially that it passes quality control, or even just start creating kind of a log or paper trail that certain work was completed at certain times, you can do that basically by using AI and a custom trained object detection model. And so in order to do this, the first thing you need to do is create your model. And so we're using Azure's cognitive services here. And we basically start out by knowing what we're looking for. So essentially for this demo, we have this piece of hardware here that has a variety of screws that need to go into it. And they just use a bolt and a wing nut. And essentially what we want to be able to use this system is to detect that we have 4 bolts with wing nuts attached on this piece of equipment. And that's just a very simple, quick validation we can do. And so in order to train the system, the first thing we need to do is collect a lot of information. It's been touched on, but basically a lot of these AI systems, the more information you can feed it initially, the better it's going to do. And that's going to help deal with edge cases as well, like we mentioned earlier with the shadow, right? You can train it with that additional data and it will get more refined and better the more you kind of put at it. So the first step for this is basically to take a lot of photographs of what we're trying to detect at different angles, in different lighting situations, different backgrounds, and things like that. We feed those images into a training model, and those images all need to be tagged. And so at this stage of the process, there's a human in the loop, and they basically need to take all those images and say, hey, this is what you're looking for. I'm going to tag for you that this is in fact a bolt with a wing nut on it, and it's not anything else. And the AI uses that basically as its kind of reward system to say, okay, I found what I'm looking for. And then it cross-checks that against the training data to then determine if it's correct. And it iteratively kind of goes through this process until it is fully trained itself. It then runs its own self-validation checks and then comes back and gives me a response saying, I found that in my training, I was able to get this 30% of the time, 20% of the time, 90% of the time. And based on that feedback from me, that gives me an idea of, all right, am I good enough that I can start seeing if this is going to fit my need, or do I need to provide more training? And you kind of go through that process a couple times. Usually you're going to build a couple of iterative models because you're going to find edge cases and you need to build against those before it's ready for production. Once it's ready for production, though, you can deploy it. And what it will do is it can take an image. You can forward that image to the model. It will give you a list of estimates and ideas of what it's seeing in that image. And it'll even draw out bounding boxes. So we'll show you a little video of that real quick. And so this first video is just kind of showing you from kind of end user's perspective, what would be kind of happening on their computer. For the purposes of this demo, we deliberately built this where you can kind of see everything happening, all right? We can actually do all of this directly through APIs. So the system could actually be running in the background and just giving you a response. So you can see here, we have all of these bounding boxes. And these bounding boxes are marking out the components that we needed to identify. And we can see that we've got 4 bolts with wing nuts, and we have the backplate that they need to be assembled on. And you can set different thresholds about what your minimum acceptable kind of estimate is. And so again, for this purpose, just for the demo, we set it kind of low at around 70%, but you can refine that to whatever you like. This next bit is basically showing you all of the steps that we're going through in order to make this process happen. So the object detection was that model that we initially trained. And then all of this that's happening here, this is a IA, an intelligent automation that is actually doing all of these steps to then query that model, get a response, do some logic processing on it, and then feed back the end user what the final result is. And so this is kind of slowed down so you can kind of see what's happening, but we can do this generally pretty quickly. And so a use case for this could be at the end of kind of an assembly line or at a specific point where you need to do quality control, or you just want to keep a record that a part was completed. You could have a fixed mounted camera and you can place your component there. It'll take a snapshot, do this processing and give you a go, no go response, or even just log it internally and you can just carry on with your work. And so this can be super helpful to help detect errors and then also create kind of a log of errors. And you can basically, use that information to refine your processes. One thing that I'm not sure gets talked about kind of enough is that even starting with a small process like this, we had to start by collecting our own data, right? I'm taking all of these photos and I am tagging it and I'm feeding it to this model. But once we kind of deploy this process, we are now collecting additional data every time we run this AI model. And those photos we can also then store. And so now we're building an even larger database and a larger data repository that we can then use to do other AI processes on. Because we have things here like what time was this photo taken? When was this process done? Did it pass or fail? And you can then go in and use that to build another potential model that can then tell you, okay, are there specific shifts or specific machines that are giving me more issues? And then you can, use this information and feed it basically back into itself almost recursively. And so the key takeaway here basically is, if we build a custom object recognition system, we can use that to help detect any errors or issues in our manufacturing processes. And kind of for your own reference, I mentioned, that as you go through and you train these iterations, they're themselves going to give you some feedback about how accurate they are. And that's going to inform you on, okay, do I need to do more work here before I deploy it? Is this good enough? And so you can actually see here on the right-hand side of the slide, this particular iteration 4, actually it's doing okay. It's at about 80%, but we actually probably want some more. So we actually went and then trained this 2 more times. We're on iteration 6 now, and we're just adding more data to the initial training set. And we've gotten up to about 95%. And that's the basic use case here.
I wanted to add on that the tools we selected on this one, because the use case was for a defense manufacturer, they're all GCC high compliant, right? Right. I'm right on that, right? Okay.
Yeah. So thank you, Ted. I forgot to mention that.
No,
So
it's okay.
yeah, so these services do run in the cloud, but they are FedRAMP and DoD1 compliant. So you can use them for those purposes. And these are specifically Azure tools. At SphereGen, we do a lot of work with Microsoft tools, so we're very familiar with kind of those offerings. But I want to be clear that this isn't something that you can only do with these tools, okay? There's a lot of these AI tools out there, and they have very similar capabilities, and it's going to come down to kind of what your tech stack is already using or what you would like to use. All right.
Questions on that? Go ahead and do. For the online
Yeah.
audience, say again.
So one question you mentioned was like you went through a few iterations. So is there any capability to use synthetic data? So especially with images, right? So I don't know. I'm just, that's one of the things I'm interested in knowing.
Yeah, so definitely you can feed the system whatever images that you want to feed for training data. And so if you want to specifically kind of exclude things, you can feed it things you want to exclude. The key point here though is that, yeah, it doesn't need to be photos. It can be synthetic information. But for the purposes of this initial training pass, the data that I'm feeding it, at some point, I still have to go in and tag it and tell the system that this is what's in the image. But correct, like I could be giving it watercolor paintings, I could be giving it sketches, I could be giving it photos. I can take all of that and use that as part of the training data. Yeah, there's no kind of limitation as long as it's in the right image format, you know, a JPEG, a bitmap, things like that. It doesn't matter if it's physical world, virtual, 3D render, it can take all of those things. And that's actually an excellent point because one of the other use cases, not in manufacturing though, is, you know, some folks are kind of training this to try to detect forgeries of like famous paintings, right? And so they kind of know what the artist's style is, and then they can say, oh, well, this is really close, but like something's slightly off here. Maybe you should take a closer look at it. And so, yeah, it can take all sorts of information.
Good question. Other questions? Does this make sense? We were trying to go through 2 demos today where I actually show you stuff that it's hard to show, to be honest with you. It's difficult to show an AI engine in work, but this is the demos we came up with today. Okay. I think that was all for our slides, right? Oh, yeah, sorry. More? Yeah.
So one question that did come up online was, what is your opinion of Bard, B-A-R-D? I personally do not have any experience with Bard versus ChatGPT. Didn't know if you guys had.
So I've used Bard a little bit. Generally, what I have found is all the systems do a reasonable job of kind of, you know, giving responses the way you would expect a large language model to do. But at the moment, it really does kind of seem that ChatGPT is holding on pretty tightly to that first mover advantage, and they have a little bit of a leg up at the moment. That said, everybody seems to be catching up pretty quickly. And for myself, in my personal life, I do a lot of art and things, and ChatGPT is not my preferred system for generating images at this point. You can use systems like Midjourney, and some of those other advantages is that you can actually pull those systems down onto your local device and tweak them for your own personal use. And so kind of like what I just showed with the object recognition, that's a custom model, right? There wasn't a model out there that could find what I was looking for. So I made my own custom model. And so what I think makes certain, you know, off-the-shelf AI systems a little bit better for certain use cases is whether or not they let you customize them. And some of the systems will let you do that. And then you can basically have your own kind of homegrown bespoke system, which is great.
So yeah, our general position from SphereGen's perspective is we'll use any AI engine that makes sense for that use case, and some are better. So I just wanted to touch on, and you brought up a couple of, so I'm gonna put you back on the spot, about training videos and about CRM data and project plan IDs and using it to generate CNC programs more quickly. These are all areas that you and CCAT are researching, right? I want to.
Yeah, correct. So some of, you know, as we tour and meet with and work with manufacturing companies here in Connecticut and throughout the region, and we start to get into the discussion of, you know, AI and the use cases for AI. Some of the interesting questions that come up are, you know, around workforce development, or I shouldn't say workforce development per se, but maybe like specific training, like specific machine training, on machine training. As an example, you know, we onboard new engineers from time to time, and we have, as you can see, a number of different systems here at the lab. So how can I benefit from using AI to train, you know, the new engineer? One of the ways in which, you know, we could do it, one of the applications is that, you know, you take a video of the training process. So I can go through and train somebody on a particular piece of equipment, but then can we give that video to AI so that it can break it down and make it searchable? You know, recognize the voice, convert that into text. And then if somebody wants to know in the future, oh, how do I, you know, one thing is watching the video and then getting trained on the piece of equipment. But then, you know, as you're using the piece of equipment, you think, okay, how do I do this? I forgot. Can you just type a question in to the AI that has that video, as its source, and then can it actually just give you the answer? That way, you're self-sufficient, and that video becomes a searchable document in essence. And then using AI against existing CRM data to generate targeted marketing material. I think all companies deal with this all the time. We're holding an event today. We have a lot of, we deal with a lot of companies. We have a pretty large CRM database. If we're holding an event on AI, or if we're holding an event on CMM programming, or if we're holding an event on model-based definition, who are the folks that we should invite? Should we, should we just blast it out to everyone, or should we have a targeted group that comes in here that we know they're the decision maker, or they're the engineers, or they're the people that are on the machine? So using AI to do some of those more kind of practical. And again, you can see, automated quotes based on historical quotes that you've sent out. So if you have a similar type part that you're getting requested to produce, do I have a model that's been trained on similar type parts that the AI can just generate the quote for me? And then again, CNC programs. Now that's getting more technical. That's machine language. Can we, what are the possibilities, right? This is getting more and more into now, kind of from the front end business side, and now to the kind of the back end production manufacturing down on the floor, now machine language. So.
Pass over to, is there other questions?
Yeah, so a question came in the chat about the object recognition trainer. The gist of the question was basically, what is the trigger for the system? And then is the training process kind of continual, or do you kind of ever kind of finish with it? So the key thing here is that generally what we're finding is that the training does still continue, but it basically is going to continue kind of at a slower rate after you basically get to a point where you feel that you're ready for production. Once you have it in production, essentially the only time you're going to retrain the model is when it kind of trips the fail-safe multiple times. And what I mean by fail-safe is we've mentioned a couple times that we generally have a threshold set where we're still going to feed information to a human user for them to validate something if the AI model, for whatever reason, can't figure it out. And generally, this is going to be pretty rare once you're at a point where you're comfortable putting it in production, but it will still happen. When that happens, that's also kind of the point where we're going to potentially gather all of that information and go, okay, hey, this is where the AI is having problems. These are those specific images. And now we are going to feed those back into the system and train it on those images it had problems with, and with a human to call out, this is what you should have actually found. And so the process does continue, but depending on the use case, it should kind of slow down a little bit and not be as rapid as, we're sometimes, when we're doing our initial training, we're running maybe a couple iterations over a day or two, and it should kind of slow down after that. As far as the trigger to actually cause this process to go, for the purposes of our demonstration, it's similar to the material cert. A photo gets taken and an email gets sent, and there is a robot monitoring the email. When it gets the email with the proper header on it, then it downloads it and does all of its work. In a production scenario, this would actually just be an application, and everything would be done through APIs rather than the graphical interface that we showed for the purposes of a demo, right? So as Ted mentioned, it can be a little bit difficult to kind of showcase what's happening on the back end, because we can basically make it so it's all code. You don't really see anything happen. All you know is you just got a result returned to you that said this is good or it's bad. And so we would just have, a little small computer hooked up to a camera, and it would just be constantly monitoring. And every time you took a picture, it would reference that most recently took picture, store information into your database, depending on what information you wanted to save, and then also give feedback to the user who took the photo. And very frequently in cases, we generally just kind of have like a green or red light, and it's like a go, no go, or you can potentially customize that feedback into whatever you would like. So I hope that answered that question.
Any other questions? No? So thank you so much, Ted and the team, for the great presentation and showing, actual demonstrations of the use of AI. Up on the screen here, you'll see the, if you want to contact SphereGen, you see the emails there up on the screen. At this point, I would like to invite up my colleague Eileen Candles to talk about the grant programs that we have available.
Thanks, Nasir. Hello, everyone, and hello, virtual audience. So CCAT provides a lot of different grants and programs that we administer on behalf largely of the state of Connecticut and the Manufacturing Innovation Fund, or at times federal grants and grant funding. So what you'll see listed here, I just want to reference briefly, we will probably be sending out at least this slide. I'm unsure if we're sending out the whole slide deck. Following, we'll also be including the survey, and you'll have my contact information to discuss any of these with your company if you are a manufacturer and want to have a better or deeper understanding of these programs. So I'm not going to go into a lot of detail at the moment, but just if we think of these and group them, the grant programs you see in columns for technology or capital equipment grants, then workforce grants, and training opportunities. One of the things that's important to notice is the icons along the lower right-hand bottom of the slide. For all of these programs, you do need to be a manufacturer or an allied service provider company. You do need to be in Connecticut, or if you're interested in relocating to Connecticut but aren't here yet, you'll have to have a conversation with my colleague Paul Strebel about that and the nuance of that. And you have to be registered and doing business for a minimum of 3 years, generating revenue. These are not funds for a startup for year 1, year 2. It's you're at least 3 years old with registered and doing business in the state of Connecticut. You do also have to have a minimum of 3 employees, and many of these programs have different employee headcount caps. The headcount caps are only your Connecticut employee base. So if you're an organization that has 299 in Connecticut and 1,000 somewhere else, that's okay for our grants that are for companies 300 and less. So there's little nuances like this, and all the details are on our website. The ccat.us/programs is a great site to visit where you can drill down to all of these. But just very briefly, for the technology or the capital equipment grants or the Syrian cyber assistance support programs, all of those, you have to apply for those in advance of signing a purchase order for the opportunity. You cannot have already signed it. It is not a reimbursement. You have to become pre-approved. And the most exciting program that's live right now is our additive manufacturing adoption grant for a $100,000 award. We'll be awarding 6 of those, and the applications are open till the end of February. If you're interested in additive, we have another event next week, January 31st. You could return or send some friends or colleagues to that. And again, as you heard Nasir say, the innovation voucher program or the manufacturing voucher program could potentially be applied to use and adaptation of some of the technology you heard discussed today. The workforce grants, those are all reimbursement programs. And I help really lead the internship program. I'm catching a note. We have to update that slide. It should say manufacturing intern program because it can be engineer or non-engineer students. But it is a summertime program to help create community and provide those interns with insights into a variety of companies besides a great internship they might be doing with you. Career Connect Rev Up training is a federal fund and grants for up to $7,800 for a manufacturer of less than 1,000 employees for up to 10 people running through this year. And it's a blend of upskilling, you align a mentor, and we help you with some great free training. And digital transformation, additive technology training, as well as what we can provide through what Nasir described earlier at our digital thread lab that just opened yesterday, just had classes start yesterday. Happy to discuss any of those with you offline as well. So I think my contact information might be, well, here's some upcoming events, Nasir. I can just touch on these briefly if that's okay with you. So always ccat.us/events. You can see all of our programs, but the Additive Support Open House, another tour, quarterly tours we're now doing for community or companies. February 21st will be that date. And then free to Connecticut manufacturing employers is a career fair at Quinnipiac University on April 11th from 3 to 6 p.m. And we have information that's going live in the next couple of days on our websites posting about that. Always, you could also access our on-demand video library. We have many of our past recordings are also on YouTube now of different technical content. And here's Nasir's contact information and mine. And Nasir, I will pass this back to you.
Thanks, Eileen. So please consider CCAT your applied R&D center. That's what we're here for. If you ever wish that you had a place at your company where you can go in and just test different systems, whether they be manufacturing, inspection systems, software, if you had, a what if type, thoughts in your mind, please do come to us. Consider this your lab. We are here to test out different solutions for you at little to no cost to you because of, as I mentioned earlier, the state and federal programs. We'd love to do formal introductions to SphereGen. If you want to contact us or contact SphereGen directly. Again, we'd love to be able to onboard you to our digital transformation program. The unit of measure of success of that program is how many companies adopted the technology and realized benefits from that technology. This is the information we want to send back to the state of Connecticut so that we can continue programs like this for you. So please do reach out if you even have a slight thought about what AI can do for your company. Thank you again for your time and have a good rest of the day.